Hey everyone, this is a lesson on solving equations. Solving an equation means that we need to get our variable by itself. Whatever variable you see in that equation needs to be isolated, all alone on one side of the equal sign. So we're going to talk about the steps that are necessary to do that. And like I said, you know you're finished solving when you have that variable by itself, nothing else attached on one side of the equal sign. So your strategy here, first off, is going to be to look for things that need to be distributed and also combine your like terms. So like terms are the things that are alike. Your plain numbers can go with other plain whole numbers. Your similar letters can go together, so you'll be on the lookout for that. When you get ready to move to the second step, you're going to start using opposite operations to get rid of what you don't want. There are lots of things that are going to be attached to your variable that you need to get rid of. So we're going to use those opposite operations of what we see to do that. Lastly, we'll need to look and scan through and see if there's anything that needs to be reduced or simplified to our final answer. So we're going to take a look at this example and follow those steps that we just took a look at. Solving for x in the following equation. Our strategy is to, remember, look for things to be distributed and combine like terms. I don't see any grouping symbols here, so I'm going to start with identifying the like terms. So I've got two x terms here. Then I've got two plain numbers here. So these things can come together on this side of the equal sign. So we'll have 4x plus 2x, which gives us 6x. You can see that down here. And our negative 8 plus 1, which gives us negative 7, equals 5. There was nothing else on the right-hand side of the equation to come together with this 5, so that's all we've got over there. So 6x minus 7 equals 5. And now, I don't see anything else that could come together on each side of the equal sign as far as like terms goes. So I'm going to start looking for opposite operations that need to be used to get the x by itself. So I've got 6x minus 7. So the opposite of minus 7 is going to be to add 7. I need to get rid of that 7, so I'm going to use the opposite of minus 7. So if I add 7 to both sides here, must do everything that I choose to do to both sides of the equal sign, then those 7's are going to go away, which is what I want to happen. And I'm going to be left with 6x equals 12 if you look down here. Okay? Now, I'm not finished until x is totally by itself, and there is a 6 attached. We don't want that 6 there. So, opposite operations. We have 6 times our x. Anytime a number is attached to a variable, that operation is multiplication. So, the opposite of that is division. So to get rid of that 6, I'm going to need to divide it out from both sides. So once we do that, 6x divided by 6, and then my 12 divided by 6, I will be here at x equals 2. So we're going to look and see that, make sure that our variable is by itself, and it is. And the value on the other side, we're going to see if anything needs to be reduced or simplified, and there's nothing I can do to 2. That's perfectly fine. So x equals 2. 2 is my answer. So let's take a look at this second example. Remember we talked about looking for things to distribute or combining like terms. Well, this one does have some grouping symbols, so we're going to need to distribute this coefficient. So when we carry this 3 over to this group, we are going to have 3b plus 12, because we're multiplying that 3 into that group. We're going to copy everything else down the same. And we're going to arrive at this new statement, 3b plus 12 minus b equals 9. We distributed our grouping, and now we need to scan across and look for like terms. So I can see here that I've got a 3b term and a minus 1b term. Those can come together. When they do, we're going to have this 2b and bring everything else down, plus 12 equals 9. So here we are. Step 3, we need to start looking at opposite operations. What do we need to get rid of to get our b by itself? Well, I can see that I have a plus 12 on this side with our b and a 2 times b. So I'm going to need to do the opposites of those two things. Plus 12, the opposite is going to be subtracting 12. So I need to do that to both sides of the equal sign, and when I do, those 12s on the left-hand side are gone. They've canceled each other out. And bringing everything else down, I'm going to have 2b equals 9 minus 12 gives me negative 3. The b is not quite all alone yet, and it has to be all alone for us to be finished. So since this 2 is being multiplied by our b, we're going to need to divide it out. So we're going to do that on both sides. And yes, we are going to have a fraction final answer, and that is okay. We just need to make sure that it doesn't need to be simplified. There's nothing I can do to reduce negative 3 over 2, so I'm going to leave it like that. Remember, as long as your variable is by itself, you are finished. It doesn't matter what is on the other side of the equal sign, whether it's a whole number, a fraction, or a whole expression. As long as you've got that variable by itself, you're okay. Okay, let's review what we talked about. Remember, when you're asked to solve an equation, you are being asked to get the variable all alone. So you're going to start by adding like terms and distributing any grouping symbols, and then use your opposite operations to undo everything that's next to your variable. Anytime you decide to use an operation, you've got to do it to both sides of the equal sign to keep that equation balanced. And you are finished, you are totally finished when your variable is all by itself on one side of the equal sign. So this concludes our lesson on solving equations.